Students, today's session we are going to see Raoult's law. What is the statement of Raoult's law? The partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in solutions. Okay, so solutions means we may consider there are two components present, solute plus solvent. So it may be volatile solute or non-volatile solute present in a solvent. Okay. So here the partial pressure directly proportional to the mole fraction of the solutions. Okay. Solution means component A and component B, or component 1 or component 2. Okay. So here suppose we have to take a closed container. So let me take an example for alcohol mixed with water. Here the alcohol is a volatile substance present in a solvent. Okay. So while we are going to heat this mixture, the mixture of solutions, first the solution it gets boiled. After applying heat, the liquid, the boiled liquid, it gets evaporated. Okay, so evaporated, so that is it gets vaporized pressure. Okay, so the first in the mixture of initial pressure of alcohol is alcohol mixed with water, we consider that is a P1 partial pressure. After it gets evaporated, so that is the vapor pressure of the pure component, that is vapor pressure of the pure component, that is P01. Okay, P01. So it will not go outside because it is a closed container. At one stage the pressure exerted, the atmospheric air pressure, it condensed and it returned back. That is at the time the vapor pressure and in the condensed pressure, it attains the equilibrium in nature, that is the boiling point of the liquid. Here this is a partial pressure. The partial pressure it gets evaporated, that is vapor pressure of the pure component. Which one is the pure component? Here the solutions, the presence of component 1 is ethanol. Ethanol it gets vaporized form, that is the vapor pressure of pure component 1, P01. Okay, so according to this statement, for component 1, partial pressure directly proportional to the mole fraction of the solution, mole fraction of the component 1. Okay, so here the P1 proportional to x1. Okay, so the partial pressure 1, the component 1 equal to P01 x1. Here the P01 is vapor pressure of pure component 1. Okay, simultaneously for component 2 also, that is P2 proportional to x2. P2 is a partial vapor pressure of component 2 and the x2 is a mole fraction of component 2. Okay, so these two equations, according to the Dalton's law, the total pressure, okay, total partial pressure equal to the sum up of partial pressure of P1 and partial pressure of P2. Okay, that is the partial pressure of the component 1 and partial pressure of the component 2. Okay, so here P1 equal to, we know that P01 x1 and P2 equal to, we know that P02 x2. Okay, this is okay. We know that for binary solutions, the mole fractions of x1 and x2, that is 1 equal to 1. Okay, so this is equal to 1, we very well know that. Okay, so x1 equal to 1 minus x2. Okay, substitute the x1 value to the equation 3. Okay, so total partial pressure equal to P01. Here the x1, the value we know that 1 minus x2 plus P02 x2. Okay, so here we have multiplied with the P01 for P01 plus and minus P01 x2 plus P02 x2. Okay, so here P01, rearrange this factor P02 x2 minus P01 x2. Okay, so for x2 is the common for these two. Okay, so take rearrange this equation, P01 plus P02 minus P01 into the common x2 factor. This is the equation for vapor pressure of the liquid solution. The graphical representation for Raoult's law. Okay, so the vapor pressure plotted between the plot between the vapor pressure and the mole fraction. Okay, so suppose this is x-axis, this is y-axis. Suppose we take compound 1, the mole fraction increases 0 to 1. Okay, mole fraction increases 0 to 1. Same time pressure also increases. Okay, for component 1 pressure also increases P1 to P01 vapor pressure. Okay, because of partial vapor pressure of the each component of the solution is directly proportional to mole fraction present in the solutions. Okay, so next we have to take component 2. The mole fraction increases 0 to 1. Okay, at the same time pressure of the component 2 also increases. So P2 to P02. Okay, P2 to P02. This is component P1 and component P2. The total pressure equal to the sum up of P1 plus P2. Okay, that is partial total pressure equal to this P1 plus P2. Okay, so this case it shows that the P01 less than that of P02. Why? Because of here the C2H5OH ethanol is a volatile substance present in the non-volatile solvent like water. Okay, so its vapor pressure is less than that of water. Okay.